This first example of projections is just going to be one to show us how to use the formula itself. We're not going to go into the why or any real practical application yet. We're just going to learn about how to use this formula. So in this example, which you'll see a couple in your homework like this, it says to first of all find the vector projection of u onto v. So that's task number 1. Vector projection of u onto v, and we have this formula down here that we just talked about in the last video, and we're going to apply this formula in this problem. Part number 2, it says then write u as the sum of two orthogonal vectors, one of which is the projection. So when we look at this one, when we think about the projection, we're projecting u onto v, so we're shining a light source really from like right here. What I like to do to visualize this a little bit better is to turn this thing. Turn it a little bit and think about the light source now is coming from up here. And we're going to shine down directly perpendicular over that, and we get the projection of u onto v. So in part 2, it says to write this also as the sum of two orthogonal vectors. So we've got those two orthogonal vectors. They're going to be u1 and u2. So when we do that, we're going to make a sentence out of this, an equation sentence saying u1 plus u2 is equal to u. That's going to be our goal in the second part of using this equation. So we'll start off with the basics first. We're going to just find out what is this blue vector, find the projection of u onto v, and we're going to use the formula for that. So projection of u onto v, and we're going to plug things that we have here. So according to the formula, it's u dot v up on top. So that means 3 times negative 2 plus, then we have negative 7 times negative 6. So all of that's on the top of the fraction. On the bottom, we're going to have the magnitude of v, the one that we're projecting onto. We're going to have the magnitude of this squared. Now if you remember from the last couple of days, we did magnitude formula, and so that is negative 2 squared plus negative 6 squared. Square root of that, but then we're also going to square the magnitude, so it really is just going to undo the square. It's going to sort of just take care of that, and then all of this is going to be multiplied by the vector v, which in this case is negative 2, negative 6. So it's a lot of stuff to start off with, but we're going to simplify a piece at a time. On the top here you got negative 6 plus 42, so that's going to be 36. On the top of the fraction, on the bottom of the fraction, the square root and the square undo each other, so we've got 4 plus 36, and so that is 40. So that all just boils down to a fraction 36 over 40 times negative 2, negative 6. And we do want to reduce this if possible. That reduces to 9/10 multiply it by our vector. And then we want to just simplify that as well. So we distribute this fraction in, simplify the numbers, and what we get down to is negative 9/5 comma negative 27/5, just reducing, distributing, and then reducing those numbers. So what this is going to be from up here is the blue vector. That's our projection, and so this is equal to u1. So we've done the first part, we've done number 1, and now let's start the second part. Well, we want to express this red vector u as the projection as the sum of two orthogonal vectors, one which is the projection, that's this one right here. So we have u1 plus u2 equals u. And we're going to just set up this equation and find the missing piece. So we know what u1 is. We know, we just found that one. That is negative 9/5, negative 27/5. We don't know what this green one is right here. We don't know what that value is, so we're just going to put that in as u2. We do know what the red one is because the red one was given to us at the beginning. That is this original u vector, and so that's going to be 3, negative 7. All right, so we got that set up. Now it's just a matter of kind of doing some basic equation solving to get u2. So u2 is just going to be taken from looking at, okay, negative 9/5 plus what x value equals 3. So really all we need to do is actually, kind of like solving an equation, add 9/5 to both sides. 3 is going to be 15/5. So if we do that, thinking about the component form of u2, 15/5 plus 9/5 is going to be 24/5. That's the x part. Then we have negative 27/5 and negative 7. So this will be negative 35/5, and we're going to add 27/5 to it, and so that's going to give us a result of negative 8/5. And so now we have that vector. So the blue plus the green is equal to the red. That was the second part of this problem. That is the sum of two orthogonal vectors. And we found the projection at the beginning. That was this one. And so now we've accomplished both of those tasks, and you'll see that in one or two problems in your homework.